Continuing through with chapter 9, so far we have talked about the particle theory and the properties that make a material either a solid, a liquid, or a gas. The other day, then, was it Thursday, we did diffusion, and hopefully you got to do your experiments. It seems as if most people did. So today we're going to move on to changes of state. Okay, so we've established that the three states of matter are solid, liquid, and gas. So now we're going to talk about moving from one to the other. So a solid becoming a liquid becoming a gas becoming a liquid, and so on. Okay. So the way you change state, or you get a material to change state, is that you either give it energy or you, I suppose, take energy away. Okay, and for the most part, this energy comes in the form of heat. Okay, so if you take, we have here a piece of ice, and you want to turn that piece of ice into liquid. So the ice is solid. You want to turn that piece of ice into liquid. What do? You give it energy, and normally you would heat it. Okay, our fridge got blocked here yesterday. Turned out a leak, as in not an L-E-A-K, an L-E-E-K, vegetable, had like blocked up the back of the fridge, and it built up this big chunk of ice. I mean, it was massive, like it was half the size of the fridge, and the weight of it coming out, like, and we were trying to get it, like, cause it was so big it wouldn't fit in the sink, so we were trying to get it to melt. So we were like, boiling the kettle and throwing boiling water over it, because we were providing heat to try and get it to turn into liquid as quickly as possible. Okay, so I suppose, I mean, you can read the bit up here, but we're going to talk about it down here. We're going to talk about the language around state changes. One thing to note, though, which is very important, is that when they change from solid to liquid to gas or back, that this is a physical change. Okay, no new substance is formed. There's no change in mass. So however much, like if you put 2 or 3 ice cubes into a beaker in the lab, and you put them over a Bunsen burner and heat it up so that it turns from a solid to a liquid, the amount of mass, do you remember mass was like similar to weight but not the same? Okay, the amount of matter in an object. So the amount of mass in that ice is the same as the amount of water that you have. Okay, its volume will be different. It will take up a different amount of space, but it will weigh the same. Okay, so if I were to put it on scales, it would weigh the same. Okay, so no new substance is formed. We're still talking about water, just in different forms. There's no change in mass, so if I were to weigh it as ice and weigh it as water, you would get the same answer. And the reaction can easily be reversed. So I could take that now cup of ice, go into the freezer at the back of the lab, put it in and turn it back into ice. Okay? So that little sentence there is very important, that when you change state, it is a physical change. And what does that mean? Okay, because we're going to talk about, as we go forward, we're going to talk about chemical changes, and they're different. Okay, so it is a physical change. What is a physical change? It's when no new substance is formed, there is no change in mass, and the reaction can be easily reversed. Okay, so 3 kind of bullet points for what is a physical change. Okay, so that definitely needs to go into your notes. Now, the stuff that's up here, we're basically going to talk about down here. Okay, so what we have is, over here we have a solid. Okay, so this here is the solid, obviously, as you see it, and this is it in terms of the particle theory. Okay, nicely, tightly packed, no space for them to flow or move in between. Okay, now if you put energy in, okay, energy in means you're going to heat it, yeah? Then look what happens. So the red arrow matches the red arrow. If you heat it, it will melt. Okay, so melting is when it changes from solid into liquid. And again, here we have liquid as you know it, a glass of water. Here we have the liquid in terms of the particle theory, which is the that the particles have space to just pass by each other. There's just a couple of gaps. So that, remember, liquid can flow and liquid can take on the shape of a container, so it can change shape. Okay? So if you have a solid and you give it energy, so you heat it, it will melt and become a liquid. Okay, so if we continue in this direction, which is the heating direction, the red arrow is the heating direction. So if I put more heat in, okay, so what will happen is both evaporation and boiling, we'll talk about the difference between them in a second, but essentially you will hopefully start with some evaporation, then you will reach boiling, and you will then be in the gas stage. Okay, so if we start from cold and basically going in this direction, we are adding heat. The solid will melt and you will have a liquid. The liquid will evaporate and boil and you will have a gas. Okay, so I'm just going to have a quick look at this in the Phet Simulations. I'm going to show you how to get to this rather than sending you the link or whatever, because like I said, you'll have a look. Right, so here's my solid. Okay, and I'm going to just talk about heating it. Okay, so I'm going to add heat to it. So you can see the solid there. If you kind of concentrate on one of the little particles, none of them are passing each other. They're all staying in their own individual spot. They're just vibrating. Okay, we said the particles move, but they're not passing each other. You can see that the ones around the edge have a little bit more energy, and they'll be the first to go once I give them some heat. But definitely none of the particles are passing each other. So if I introduce some heat, okay, now look at, pick a particle and kind of look at it, okay? Now they are slipping and sliding. You've got one escaping there already. Okay, so I give it a bit of heat and there's way more energy there and there are gaps and they're starting to pass each other a little bit more, and they're starting to pass each other. So you're talking about, now I've given it heat, so what's happened to this solid? It has melted and it's moving into a liquid state. Okay, so if I give it even more heat, okay, now you can see the gaps are increasing and now we're moving into a gas state. So at this point we're talking about boiling and the liquid is no longer liquid, it's now a gas. Okay, so we'll just have a look at that again. So there's your solid. Introduce some heat and now the particles can move past each other. You can see the shape is changing. So we've moved into a liquid state, maybe not quite, maybe there. And then if we keep going, more heat, more heat, more heat, we go through the evaporation and the boiling stage, and we move into the material is no longer liquid and it's now a gas. Okay? So that's the heating direction or the getting hot direction. But obviously, as we said, it's a physical change which can be reversed, so we can go in the cooling direction. Okay, so if you start with a gas, and instead of giving it energy, putting energy in, you take energy out, which essentially means you cool it. Okay, you remove the heat, you cool it. Okay, so if I take a gas and cool it, it goes through a process called condensation. And you'll have seen condensation like on the windows in the car and stuff. So condensation is when a gas turns back into a liquid. And then if we cool that liquid further, we talked about that, so take it and put it in the freezer, you will freeze it and bring it back to a solid. Okay, so obviously the states are important. You need to know the heating process, which is solid, melting makes liquid, evaporating and boiling makes gas. You also need to know the cooling. So gas condenses to make liquid, and that freezes to make solid. Okay, so you need to make sure you know all those words. We'll have a look here again, and we'll start with our gas this time. So there's the gas, plenty of space between the particles. They're certainly moving past each other. So what happens now when I take the heat out? So I'm going to cool it. Okay, so you can see they're losing energy, they're slowing down. Okay, okay, now I know there's still some up here, but down here you can see they're slipping past each other, but they're much more tightly packed. So we're moving closer there to the liquid phase. And then if I keep cooling it and try to get them to now, there, you can see that they essentially look like a solid. Okay, very little movement there at all. Still a bit of slip. No, they're not really passing each other. They're just in the spot vibrating. So that's now a solid. Okay, so if we go back, to a gas, so I cool it. The gas condenses in this cooling process and becomes a liquid. Okay, so that looks liquidy there. All those little things are slipping past each other. And then if I cool it further, it will freeze and become solid. All right, so there your phase changes, and you can play around with this and have a look at what heating and cooling does to the particles. So just two other points quite briefly. Melting and freezing, this is more about the melting points. So when an ice cube melts, the heat causes the water particles that make them up to vibrate fast. So you could see that in the simulation. So when it's an ice cube, it's solid. So when it's solid, you've got that nice structure where they're all tightly packed and nothing can slip and slide past each other. But you introduce heat to that, and then you start messing with this, and they get a little bit more space, and all of a sudden they can pass by each other. And once it gets to this stage, you're talking about that it has melted and it's now liquid. Okay, so the temperature, now this is important, okay? The temperature that substance that happens at is called a melting point. And the melting point of ice, so specifically talking about water here, you should know this probably, but it's 0 degrees. Okay, so the temperature that a substance melts at is called its melting point. Now, not every substance has a different melting point, but there are different melting points. It's not that everything melts at 0 degrees. We're just specifically talking about water here. Okay, so the melting point of ice is 0 degrees. And then cooling the liquid takes the energy from its particles so they can only vibrate and not move around. So say going in the other direction. So, if you take the heat out, then what happens is the energy that they have here in a liquid state, that gradually reduces and it brings you back here. Okay, and then you have that it has undergone the freezing phase, and you'll see here, so when a liquid changes into a solid, it is called freezing, and again, the point is the same. Okay, so the freezing point and the melting point are the same. Okay, just like the condensation point and the boiling point will be the same as all, which we'll talk about. Is that all right? So just make a note of this, okay? Now, we do tend to refer to it as a melting point as opposed to a freezing point, but just to note that they're the same thing, essentially. It's just when you talk about a melting point, you're talking about the heating up direction, I suppose. And when you talk about a freezing point, you're talking about the other direction, the cooling direction. Okay, so just a brief note about there's kind of a difference between evaporation and boiling. Okay, so both evaporation and boiling would cause a change in state from liquid to gas. However, they take place slightly differently. Okay, so you could see it in the simulation, and I'll go back to the simulation, but it's underlined here. In a liquid, some particles have more energy than others. Okay, so you could see that it's normally the ones at the edge. They tend to vibrate a little bit more vigorously. And once you apply any heat to the situation, they escape first, okay, because they had more energy than the others to start with. And the particles with the most energy leave the surface. They spread out and they form a gas, and that's evaporation. Okay, it is not like the liquid does not bubble. It doesn't like so when evaporation is occurring, it means that some of the liquid is turning into a gas, not all of it. Okay, that's the big thing. Okay, evaporation happens at all temperatures, and it'll happen like puddles. So if you have rain in a puddle and it dries up, as in it stops raining, and then the sun comes out, those puddles will dry up. Now they haven't boiled. Like there was no point that you missed where the water in the puddles were bubbling before they boiled off. What's happening is they're evaporating. So the surface particles are gaining enough energy and they evaporate. And then there's a new surface particles and they gain enough energy and they evaporate. But at no point does the entire puddle become 100 degrees and boil. Okay? So then boiling is when all the particles are involved. Okay? All of them have enough energy to break free, become gas. Okay, so that's the main difference. Evaporation is just when the surface particles have a little bit more energy than the rest of the liquid, and they gain enough energy and they break free. But the entire liquid, all of the particles in the liquid are not involved. Whereas in boiling, that's when all of the particles in the liquid have been given enough energy to turn into a gas. Okay, and then important to note, the temperature at which this liquid changes to gas is called a boiling point, and the boiling point for water is 100 degrees. Okay, so evaporation is a much slower process than boiling. So like, you can boil a kettle in a couple of minutes. Like we can get water boiling in a lab with a Bunsen burner pretty quickly. And the evaporation of the puddles could take hours. Okay, so this is another kind of important thing to note here. So evaporation is a much slower process than boiling because, you might get the first kind of high energy particles to escape the surface of the liquid. But then you have to wait like for the next highest energy particles to gain a bit more energy and escape, and so on and so forth. So for a puddle to for a puddle to evaporate, it could take a couple of hours, whereas we can get water to boil in a matter of minutes. Okay, so I'm just going to show you this. I don't know if you noticed it the first time around, but we'll just have a quick look. So if I put in like just a little bit of heat to this. Actually, no, look, we're talking about liquid, so we'll start with liquid, right? So here's my liquid, right? This is the puddle or whatever. There's one gone already. If you put a tiny bit of heat in, see what happens? So these ones up here, these ones that are jumping around up here, they are evaporating. Okay, these ones down here do not have enough energy to break free. Okay, but the ones up here have evaporated. Okay, you can see it in a solid as well. So you can see these ones are almost going. Go one more jump. No. No. Afraid to go too far. I just want one or two to escape. Okay. You can, so like obviously that's not evaporation because that's a solid turning into a liquid. But this idea of the surface, that's nice there, the surface particles just having that little bit more energy, and then you put in like, so you have a puddle and you put in a little sun, the heat from the sun, and those particles escape. And it's just going to take a really long time for all of the particles to evaporate. But that's the idea of evaporation. Whereas if I like really blast up the heat and you see all the particles, now we're getting to the point where all the particles have energy. So now we'd be talking about boiling. Okay, so just a totally different process. So let's go back to my liquid. Small bit of heat, and you start to get some evaporation. So these are evaporating up here. Okay? So that's the idea of evaporation versus boiling. So evaporation is your surface particles having enough energy to escape. So they evaporate off and become a gas. Whereas boiling is when all of the particles have enough energy to become a gas. Okay? So ultimately both of them will achieve the same thing. It's just evaporation takes way longer. I just want to show you, I'm sure you've all figured this out already, but if I just, so if you just Google PHET, now I've obviously looked it up a few times so it comes up, right? So we're here. If you go into search, it's going to work now, it's going to be slow. Oh, I can't get it to search. There you go. So states of matter, which is what we're doing at the moment. Now see here, states of matter HTML5, click on that. I think this is the one, isn't it? Yeah, and then you just go into states. Okay, so that's how you get into those, and obviously then there's all the other ones to look at, but that's just have a little look at that. Alright, so that's all I want to do today, so take down those notes please, and I will send you on your homework.